Yo, 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 good morning, good morning. Sorry for the slow start. Just needed to get some things in order. There we go. So we're back after a couple of days not doing any work. So we're just gonna try and jump straight into it again. Pick up where we left off. So we're currently in the process of generating some random visual properties for our creatures, laying the groundwork for the system as well. And I just want to describe it so you viewers can get an understanding of what we're trying to do, and so that I can understand what we're trying to do. So let's say that we have something like this. It could be a mesh or a surface of type. It's gonna be a mesh most of the time, and we want to generate random visual properties on these with some constraints. So one such constraint, or let's say that we want to generate UV spheres only on this face, the top face, and we want to generate them like here and here as well, maybe. This is going to be pretty basic, but like one constraint we want is we don't want these eyes to be generated outside, like hanging like this, maybe here. So the spawn point is still within this triangle, but it makes it so that the full object is outside, right? So we have a solution where we get random points on a mesh given the triangles. So, of course, the first thing I thought about doing was just, based on the size of what we're spawning, we like add a margin to the triangles. But if we just do it as the triangles, we're going to get something like this here. Yeah, so maybe we no longer spawn the object hanging out, but we have now constrained it more than we want to. We will never be able to get a object that is spawned here because it's in the non-spawnable margins, right? And that's not what we want. And it's not visible here, but we could have, it could also look like, let's see here. We could have something that looks like this. And if we add margin to these now, we are gonna get triangles, or we're gonna get some areas of our surface where we can't spawn anything at all. So basically this solution now leads to this part not spawning anything ever. And that's not what we want. So the idea is that we go through the mesh, we create a version of the mesh that is only used for spawning stuff. We don't need to render it or anything like this. So we just need this as, we just want to reconstruct the information that is the mesh. But we go through each phase, and given a set of constraints, we merge phases. So eventually we're gonna get, like, all of these triangles, they belong to the same, they have roughly the same normal, and they share edges So if we want to spawn an eye here, the only thing we do is we create the margin like this instead. So now we can spawn an eye everywhere inside of this, but not on this margin. But to do that, we need to like figure out which triangles that share edges and has roughly the same normal, and then we need to get the outer bound, which in this example are these. I hope that makes sense. Quote, it should have a functional definition of if the mesh is spawnable. I think it's fairly similar to nav mesh. I don't know. First of all, I don't know what you mean with the first. But the thing is, yeah, of course we're gonna need to mark what's spawnable or where we should be able to spawn eyes. But like that's not the problem right now. The problem is not about marking where to spawn or not to spawn. It's like restricting or constraining the already marked area that can spawn eyes such that they don't hang on the outside. And I think the solution we have here is pretty straightforward. That's what we want to do. Like when it comes to our stones here, the spawnable area is going to be the full mesh. It's just that we want to merge, like we don't want to calculate a random point where to spawn the eye based on the triangles. We want to do it based on polygons or n-gons. That's pretty much all it comes down to. If we're talking, it should have a functional definition of the mesh as spawnable. Like we had that previously. Previously, we created our own shapes, rectangles in our case, and we placed them all over here. And then we just spawned the eyes on those rectangles. And yeah, that works, but it doesn't give us as good of a result as I want. Yo, what's up, Jax? Good morning, good morning. Tried to learn GGX Specular, but I have no idea so far. What is GGX Specular? Every day I hear terms, I have no idea what it is. Specular highlight technique, ground glass on... Oh, GGX is it's something that is supposed to replace Blindfong. Huh. You know what? I'm gonna try and learn GGX as well. Not today, though. But we're gonna do it. So I'm just gonna put it into my notepad. My ever-growing notepad. GGX. So what differs GGX Specular as opposed to Blindfong? Is it prettier? Okay, so I want to make this one work. This function will hopefully do what I want. like changing our triangles into n-gons. So we can spawn them. Let's just do this. Okay, do we need collections generic? We're gonna do mesh. Okay, so I want to test this function. Let's see what we have. Actually, it's called Cook Torrents, like Ward or Blinfong. Okay. But can you like summarize it? URP lit, use it for doing specular. Okay. Like, is it actually better or is it just different? And how much heavier is it to compute? Calculate. Yeah, I want to return something here. We want to return n-gons. So this is a AI generated solution. We walked through it roughly this Tuesday. I just want to see if it works before we go through it some more. We send in a mesh. One sec, shouldn't we have vertices here as well? Mesh vertices. Okay, great. Distribution test. Fuck, we can actually take this one. Okay. There we go. Let's test this one. It was up Unity coded, by the way. A few weeks ago, just saw this old repo about those different models. Let's copy that one and let's take a look. So many fucking BRDF models. I don't even know what that means. Disney Diffuse. Disney Diffuse. Wow, this is pretty cool actually. What are the artifacts we get here? Is that actually... Yosa Poke the Bear. But here we don't have an example of Smith GGX, do we? Keep up the good work, my G. Thank you, you too. I guess we can see the blog later on. Okay, interesting. I'm gonna keep this one around as well. 6 years ago. Okay, let's see if this one works. Distribution test. Didn't I add distribution test to one of these? I don't think I did. Or I think I did, but I don't see it now. So let's do... Yeah. Unity Code missed many streams. What's the current game completion? Fucking, that's impossible for me to estimate. Or I mean, I could do an estimate, but it's probably going to be wrong. So I pledged the 5th instead. Yeah, it's this problem we get. So when we try to make... when we try to make n-gons, or we try to sort them pretty much here, it fails. Actually, did we have any prints here? Yeah, we did. Debug. Yeah, okay, we probably fail before that. So let's try this one. We know fails. So I'm just wondering. Sometimes making it again solves. I don't know. It's just that the previous version we had, I had changed quite a few things. I just wanted to see if the... we're going to remove... Let's see what we have. Group in Polygon groups. we already know that it breaks here, more specifically here. Current is set as 2, and I think, yeah, current is set as 2 and it fails. So what I want to do is boundary. We have boundary. Let's do this instead. I would do this. Polygon groups, list int. So I think we want to do for each and we're gonna see what we get from this instead. Do we have anything here? I don't think so. We pretty much have nothing. But 3, 6. Oh, we do. It's just that we draw it over here. Interesting. Yeah, and it's the sorting that fails. Although I wonder... Yeah, we need to... It's the sorting that fails. Everything else, I wonder if it looks... This doesn't look quite all right. But yeah, maybe it's based on... yeah, okay. If we sort it, it might actually be correct. A little bit worried that we don't have anything over here. Yeah, we're gonna need to sort it. Fucking hell, I hate this. So this is a list int, I think. Group in polygon group. Edge int edge use count, get triangle edges. That's pretty straightforward. Okay, so we look and see if we have if we already have this edge. If so, increment count. Otherwise 1. Okay. Yeah, boundary edges are only used 1, so we do boundary KVP. If it's 1, we add it here. Okay. So we loop through each edge. Or for each triangle, we create an edge, and then we check how many times that edge exists. If it only exists once, it's a boundary edge, and then we add it to boundary. And then finally, we sort this shit. But, okay, before we sort it, we know that sort edge loop breaks. So I want to see... In boundary, we have edges. We just have a list of edges. And here we just build up a dictionary where we point to so given the start of the edge, the start vertex, we are given the end vertex. And it fails here on 2. And we're assuming that that index 2 exists here. Do we want to do anything? Yeah, it's weird that it doesn't. I mean, I guess this could happen if the mesh... honestly, I don't know. Yeah, if the mesh had... distribution test, let's remove it from here and do... Let's add a 3D object, cube. You know it's bad when it fails on something simple as this. Even key 3 was not present in dictionary. Okay. Okay, let's draw each edge then. Lumen's Unity runtime so slow compared to Godot. What I mean by runtime, for example, you write code and run to test it. Okay. Noted. Yo, what's up, Derek? Happy Friday, man. Let's just add... Yeah, let's just add... Boundary. Or is it select many? Let's do it like this. Add edge.v1. I thought, oh, is this one an int? Yeah. Words. 8, 8, 8, 8, 8. Yeah, that looks pretty good, actually. I think we probably get this one because we don't sort. 8. That's probably correct. Makes me curious. Sort edge loops. Actually, a little bit worried about the 8 here as well. Eight. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I get it. I get it. A little bit worried about this one though. Okay, makes sense. So why does the sort edge loop fail? Lumens, what are you trying to make? We're trying to, given a mesh, we want to transfer that mesh from a set of triangles to a set of n-gons based on a set of rules. That's pretty much it. It feels like it does this one under the assumption that the end of every edge continues, or that the end of every edge is the start of a new edge. And I don't know if that's true. What happens if we do... Like, we can't do it like that. I was wondering if we check if this one doesn't exist, then we do... Do we just want to break then? Probably not. Paints key. Current. Yeah, we're probably not going to get a very good result. Better than I expected. And if we do it on this one... It's fucking rough. Yeah. We don't even get the correct result here, do we? But I mean, that could be... Nah. Huh. I don't want to see this line at all here. Same with this one. Or actually, that one might be fine. No, probably not. No, we don't want to see that one either. Okay, so this one doesn't even do its job. This one looks good, but also... Getting this one. Okay, if we were to create our own solution from scratch... Yo, what's up, Aviv? What are you trying to do with these rocks? We're trying to... we're gonna generate some visual properties on them randomly. So pretty much we want to get a random point on the mesh, but with some constraints, and then we want to spawn stuff there, like eyes or something like that. One step in that process would be to convert triangles on the same plane into n-gons. Honestly, I think the procedurally generated creatures, yes, that would be the short and better answer. Exactly. I think the process of doing this is pretty straightforward, and I think we're gonna rock our own solution. Fuck this AI 50% solution. I think we're gonna start by just creating triangles from the data we have. Triangles are gonna have the vertices, the normal, and in fact, do I want my triangles to consist of edges? Maybe I do. Fucking hell, now we're like recreating a fucking modeling software just to create this, but yeah, maybe it's... Yeah, we're probably gonna go pretty crazy with the procedural generation eventually, so this might actually be a good entry step. Yo, what's up, Fabik? Hope you're having a wonderful Friday so far. I'm assuming that using Visual Graph to achieve this is too mainstream. Hell yeah, it is. Yankule Tito, what's up? Hope you're having a wonderful Friday as well. I don't know if Visual Graph... Like, I'm gonna be honest with you, I've never used Visual Graph. Oh, I want to use it so bad. But I don't think this is the correct use case for it. Fabik, do you remember our fire talk, David? I don't get that sentence at all, but you think it is? Maybe. Visual effects to complex simulation running on the GPU. Like, we don't want this to be a running... we don't want this to be a running process. Like, we want to... when we instantiate a new creature, we spawn it, and then we procedurally generate parts of it. Like in this case, we just want to spawn a couple of eyes on it. And then we want to keep those eyes exactly there for the rest of the... for the rest of the time, pretty much. So we're not gonna have like particles. Procedural primitives. Oh yeah, yeah. Now I remember. Fabric. Now I remember. One sec. Back. I just need to go AFK real quick. Fabric, and do you remember what did we learn? I don't. Please remind me, and I will be right back. I'm wondering about this VFX. I'm not so sure, but I'm open to being... Like, I'm open to changing my mind. But be right back real quick. Okay, back. Sorry about that. Let's see. VFX use cases, Unity. Like, isn't the full purpose of VFX to just do advanced visual effects? And I wouldn't really define this as a visual effect. Like, really, this is just a way to get, like, to spawn a couple of objects based on another object given a set of rules. Pretty much. So I don't know, like, if we just wanted to spawn 2 eyes on a stone, I don't think VFX graph is the answer. If we were to have something like a fire animated within this stone, we would probably make the fire with VFX graph. Yeah, we're gonna do a few CPU related stuff. So yeah, for this, I'm pretty sure. But I definitely want to do stuff with it eventually. But let's see here. Fabic. Yeah, sure, I'm stubborn, but like if you give me a proper like example of where it's used as we're gonna use it here, then I'm not seeing anything on a website to change my mind. Like we're gonna do like procedural generation. Yeah, please do, Fabic, please do. Like I'm open to changing my mind, but like we're gonna do, when we spawn a new creature in this game, we're gonna instantiate the creature and then we're gonna generate some features on it, and that's how the creature is gonna stay for the rest of the game. We don't need any more GPU simulations or anything like that. We just do some, we're gonna do some calculations, spawn some stuff, and then we're done. We're gonna do some crazy VFX stuff later on, but okay, so as I see as the process we want to do here, I'm gonna keep this, I want this solution to be generic because we want to use it for all of our procedural generation eventually. But as I see it, we go through the mesh, so that is vertices and triangles, and from that we create edges and triangles, but we define them in some way as shapes. So we're gonna have edge and triangle, but I think we're gonna define triangles as edges. Fabbing, no simulation needed, just for spawning. Maybe. Yeah, but please send some examples. I'm gonna look them through and I might be convinced otherwise. Yo, what's up, Mercenary Mage? Hope you had a wonderful stream, man, and thank you for the raid. Thank you, appreciate it, appreciate it. Like, look at this, like my initial example from this stream. We have a mesh. We want to get some random points on the top here, but we want to get the random points in such a way that we don't spawn anything hanging out like this. So we're gonna... I don't see how VFX could help us with this. But okay, we're gonna go through the mesh. We're gonna convert it to indices and vectors into edges and triangles. Then we're gonna go through, let's see here, fuck, do I need to, yeah, maybe we're gonna create a new issue for this. This turned out to be, and we're probably gonna, so shapes, we're not gonna have triangle and edges as shapes, not polygon either. But then when we have them as triangles and Fabric in VFX, you pass the mesh and use triangles/vertices to spawn objects. Yeah, continuously like. So what you're telling me is that we could use the VFX graph to get the random points and then we take it from there. So we just use the part of VFX to spawn the random points. We grab those positions and continue. But like, we already have an implementation for getting random points on a mesh based on triangles or vertices. But now we want to add some additional constraints here, which I don't think the VFX graph can utilize or can do. Like, I'm wondering if using the VFX graph in our case is like using an LLM to remove or to make a sentence all uppercase. I'm wondering if it's too big of a tool for the work we're trying to do, if you know what I mean. Fabric, damn it, you're making me get up from bed and turn on my computer. Be right back. I'm sorry, man. I'm sorry. Okay, so we convert this one to triangle and edges, and then we can loop through them. We group every triangle that has roughly the same normal into groups, and then we also check if they have neighboring, or if they use the same edges. If they do, we merge them. I think it's pretty easy and pretty straightforward. I think the biggest problem later on is gonna be... That's pretty much what we are doing. That's pretty much what we are doing here. Although I am wondering about the... flood fill here. Oh, should be okay. Okay. So fucking weird that it fails here. Okay. You know what? Now when I'm thinking about it, fuck, I don't know. I don't know. I mean, I could probably for now, like before I commit to doing this system, I'm wondering if we could just... we're gonna have to use some math. We're gonna have to do some math at runtime concerning polygon lines. Because the idea is that we create one of these, we randomize the size of it, and based on the size, we want to find a random point within this n-gon that won't make this one spawn outside. Pretty much. I think it looks extremely good, except for this. Except for them hanging outside or being spawned on top of each other. Yeah, it would look so fucking good. I mean, it happens extremely often as well. Now we have this one as well. That's another type of problem. There we go. Okay, the only problem I see, or the only thing that isn't as straightforward to me is, so we just convert it to triangles and edges, and when we have it as triangle and edges, we can compare, like this edge appears this many times, and so on and so on. But like if, let's say that we want to add a normal, so much like actually when we import a mesh, we can recalculate normals based on a smoothing angle. So like if we want to group the triangles here based on normals, that's the only thing I'm a little bit worried about. It's probably fine. It's gonna be one very interesting stream today. Fabric Discord, yes, I looked through it. I still don't see. One sec, be right back. Okay, I get what you're trying to say, Fabric, so that you can use VFX graph to get random points on a mesh. Like, I'm just wondering if... Like, every example I see with VFX graph is for VFX, as like for visual effects. And particles. Like using VFX graph for procedural generation. I haven't seen anyone else doing it, so it's definitely unorthodox. And like in the examples you send me, you definitely, like, you're using it for the right purpose. You're spawning, like, you're creating a fire effect and a smoke effect. It feels like what you're trying to, like, tell me is to use it to just get the random points. But why should I use VFX graph instead of, like, the same functionality exists in the old particle system. So you have something like, you have a module here. Shape. So this module right here, it gets, like, it returns random points on a shape. Fabric, do you still use particles for spawning ice? I don't think we have never used particles for spawning ice. So let's say it like this. Let's say that we have the example of, like, we have a creature with two, where we randomize the number of arms. So we have a creature. So when we spawn this creature, we spawn it without arms, and then we want to figure out. Then we want to spawn between 1 and 4 arms on that creature. Each arm is a prefab that is rigged and skinned and all of that, so we will be able to move them. Like, should I use VFX graph just to calculate 4 random points where to spawn these arms? Like, it doesn't make much sense to me. And it's not like, the problem is not only getting a random point given a mesh. That is pretty easy, pretty straightforward, honestly. We already have a solution for that, weighted by triangle as well. The problem is getting a random point on a mesh given a set of rules and the transformations. Like, this is the most simplest example here. We just have a stone base model and we have I prefabs. And we just want to spawn XI prefabs on this stone surface. We want to add some rules that they don't hang over the edges of n-gons. That's pretty much it. But then we're gonna extrapolate this system. We're gonna use it for arms later on, maybe, or maybe we have a mouth of a creature and we want to spawn a various amount of teeth and stuff like that. So, like, these are only the first simple building steps in a procedurally proc-gen system for our creatures, basically. And I would love to work with VFX graph. It's not that I have anything against it. It's just that I don't think it's the right tool for the purpose. Later on, when we do some very cool creature-specific visual effects, then we're gonna dive into it. Fabi, thank you for the explanation. no problem at all. I'm just like trying to describe the problem we have here and why I'm being so stubborn, you know. But I would love to continue the conversation on Discord after, and I definitely want to know more about VFX. I'm just extremely skeptical right now. Fabic, but what are the particles for? Like, I don't know what particles are you talking about? If you're talking about these, they are not particles. But yeah, I'm pretty sure we're gonna have to. Yeah, we could. Nah, I want to do this. I want to create. I want to create a robust system for going through a mesh, pretty much. So let's see what we can do. I'm gonna create a issue for this. Oh, we're talking about this particle system. This is like the only particle system I have in my game. It's just the glimmer particles, you know. I think that's the only particle system in my entire game so far. And I think it was created before VFX Graph was a thing. Okay, give me a sec here and we're gonna create a issue concerning this. I think we're gonna call it mesh parser or something like that. Fabic, but you had some properties defined of planes, and I thought this was for particle system. Oh, are you talking about like these? We want to make this, maybe. But we pretty much want to redefine, like, we want to have the mesh not described as something that can be rendered or anything like that. We just want a mesh object described as something we can use to calculate stuff on. Fuck, okay. And maybe I will be looking back at this and think, what the hell? What are you doing? But let's see. So it's pretty much this. We're just going to convert the mesh into triangles that consists of edges, that consists of vertices. And when we have that data structure, then we can go through that, and based on some rules, we convert it to polygons. And when we have the polygons, that's when we can spawn stuff and start messing around. Okay. Create, what are we going to call it? Mesh parser. And maybe we can call it mesh parser actually. Okay, let's see here. I want to differentiate it between, probably only going to use it for these creatures. Generation modules. We're going to put it in its own folder. Or Fabric. Okay, I'm shutting up. Just check the Discord later because I'm curious and a little bit confused. Yeah, definitely will. Definitely will. Oh, yeah, you mean... Okay, now I get. You sent me a message. The red squares we had on these previously. No, they were also used to generate the eyes. It was just that we was a little bit more... Instead of using the full mesh to spawn the eyes, we defined a couple of shapes and used those to spawn the eyes. Now I just want it to be a little bit more complex. I want to use the full mesh because it's quite boring if we only spawn eyes on predefined small areas. But okay, let's see here. We are gonna put it... I wonder if I want to put it on visuals here. Yeah, maybe generation. Yeah, we're gonna keep modules, and then we're gonna have a mesh parser here. Maybe. And then we create primitives. Yeah, that's it. Mesh parser. Vertex. Oops. So like pretty much I get the confusion because pretty much what we're doing is very similar to like parts like of the systems that particle systems uses when they spawn stuff, but we want to take it a step further, right? And we don't want to use it for the same purpose. one step further is it's not the correct. But we want to take it in a little bit of a different direction. We want to add some constraints that particles don't care about. Okay. Beautiful. Let's see here now. Modules. What are we in here? Game, creatures, visuals. Visuals. That's a bad. We're gonna rename that one, but we're gonna do mesh parser. We're gonna put this one in game, creatures, generation. Mesh parse. Mesh. Maybe. Primitives. My bad, sorry for the confusion. Didn't understand correctly what you wanted to achieve. No problem at all. Like questions like that makes me rethink the direction I'm heading, and sometimes that's good. You know, sometimes I'm doing weird shit that I shouldn't be doing. But I guess that's relatable. Yo, what's up, Aviv? Why not get the mesh, pick a random vertex, convert to world space, align with surface world normal, and then instantiate the eye? Like, first of all, then it's tied to vertex, right? We might want to spawn eyes in the center here, right? Other than that, it's pretty much what we're already doing. So look at this system. It's very beautiful. So what we do here is that we take, if you want more detailed description, you can check the VODs. But basically we're generating a set of random points on the mesh weighted by triangle sizes, and then we spawn the eyes on those points. And as you can see, they are aligned with the surface they're spawning at. But we also get issues like this when we have something hanging over the edge. That's currently what we're trying to solve. And yeah, it's easy. We can just add some margin here. But if we want to add the margin, we can't do it based on triangles because, yeah, then I went through it in the start of the stream. If we do it based on triangle, then we won't be able to spawn eyes here, basically. So what we want to do is we want to build polygons and base the margin on that instead, so it looks like this, and then we can spawn the eye here. And that's what we're doing. That's the process we're currently doing. Yo, what's up, Little Miss Murder? Hope you're having a wonderful Friday, and thank you for the sub, appreciate it. And yeah, seeing that 17-month, that doesn't feel so good, but I appreciate it. Fucking hell, yeah, time flies. God damn. Aviv, oh, the thing you're doing is way smarter. Maybe you can add a small raycast that checks how many vertices are in range. If there are 3, don't spawn the eye. Like what I'm trying to avoid with our solutions is, I'm not a very big fan of I don't know what they are called, but like repetitive type of brute force ways of doing things, i.e. spawning something, then check if it's a correct spawn point. If it isn't, try spawning it somewhere else, check if it's a correct spawn point. If it isn't, check again, check again, check again, check again, you know? So what I'm trying to get at here is like we want to analyze the mesh, present it in such a way that we can, using math, figure out a spawn point once, and while figuring out the spawn point, checking if it's correct. So like, instead of brute forcing us to a correct spawn point, I want to calculate a correct spawn point. Recursion is the most powerful. Recursion is fucking sick, man, but I don't think that's recursion. Like, you can do that brute force type of thing without involving recursion, you know. Little Miss Murder, asset creation. If you're solo, you have to accept that it will take forever. True that, true that. But like, I think it's pretty straightforward what we're trying to do here, and I don't think it's too much to ask for. This is a tough mission. We'll see. Like, this is like the entry step to this procedural generation, so it's just gonna get sicker and weirder and more complex from here onwards. But yeah. So like, procedurally generating the position of these eyes, like, I think it looks so incredibly good, or it has, at least it has some, it can look incredibly good in the future, but things like this, we're gonna have to fix it. Yo, what's up, Calvino? Happy Friday, happy Friday. What are we working on at the moment? We're doing some procedural generation in regards to the creatures. Fabric, get random triangle, get its verts, calculate barycentric coordinates, add a random direction from center, move along that direction and calculate path to nearest edge of triangle. But yeah, then if we do it like that, Fabric, then we get this problem. Like, we don't want to do it based on triangles, because then we remove too much area that should be proper spawn points. And quote, your problem is like cannot be calculated with, it has too many edge cases. No, I don't think it does. Like, what are the edge cases that doesn't work here? Fuck, man, we're just trying to create a polygon out of a set of triangles. I don't think that's too complicated or has too many edge cases. I mean, hell, Unity does it every time we import a mesh, basically. If it should interpolate or not the normals. I mean, Blender does it all the time when you're modeling. Little Miss Murder, I have an idea. Create a procedural skeletal system. I think meta blobs, but you can add features like eyes at fixed offset. God damn. Now we are moving into even weirder stuff, right? Now we're bringing out the meta blobs. I'm not saying we won't in the future, but that's not where we're at currently. I told myself at the beginning of this that I don't want to go, like, I don't want to go as deep into creature generation as Spore. What I want to do is I want to design like nice looking base creatures, and then we just want to vary a set of properties on them, you know. Fabric, you could check if the triangle selected area is smaller than the eye, pick another one. Yeah, but that's what I'm saying. That's why I'm having this example here. So if we try to spawn this eye, then this triangle is too small, right? So if we choose a random triangle based on area, we could never choose this triangle. But the problem is that I still want to be able to spawn the eye in this area, because if the eye spawns here, it won't hang outside, right? And that's why I just want to calculate a polygon or a n-gon. So we create the margin based on the n-gon, i.e. these, as opposed to each individual triangle. Or go through all triangles and discard those that are smaller than 3 times I. But that's what we don't want to do. Right, that would be easy, but it would exclude too many triangles where we actually want to spawn eyes. Let's assume that it looked like how should I like I think we have the solution. Like I'm not trying to arrive at a solution right now. We already have the solution, we just need to implement it. So like the solution is just to take a set of triangles, we join them based on some rules, i.e. almost similar normals and sharing edges. So we join all of those, and then we create a boundary polygon, an n-gon, so this one, and then we get a point within this one, and then we spawn the eye at that point, basically. I think it's a little bit complicated, but I think we can solve it. Little Miss Murder, I'm thinking of the amount of work needed to create critter assets. Automation is your friend. Like for my game, I have to draw 11k individual hexagon tiles, and it's just intractable unless I automate it. Yeah, definitely, 100%. 100%. That's like, but I want to find this sweet middle ground, you know. I still want to have creatures that I have designed that has a purpose and a lore, basically, but I want to vary them quite a lot. So it's like when fighting games or whatever, you know, when they do the cheap trick of they design one type of enemy or one enemy, the visuals of one enemy, and then they just change the color of that enemy to add a variation. I pretty much want to take that, but just one step further, you know. So we're definitely gonna have automation and stuff like that, but like I want to have some or quite a lot of say in it, right? Yo, what's up, Crazy with Atlas? What are you making? Are you asking me generally or from a macro perspective or a micro perspective? Fabric, select one triangle, get its verts, get other triangles that share those verts, and compare normals. If they are the same triangles, they are on the same plane. Yes, 100% makes sense. That is exactly what we are going to do. So we're going to go through a mesh, go through each triangle and create triangles. Each triangle is going to consist of edges, and each edge is going to consist of vertices. Then we have a nice data package we can go through, and we can analyze it. So we're going to go through triangles, and we're going to group triangles that share edges. But then we're going to add the option to only group triangles that share edges and has roughly the same normals. And when we have those groups finished, we can go through the triangles in that group and remove all, so we only have unique edges left. And when we only have unique edges left, we create a polygon out of it. When we have a polygon, we can get a random point within the polygon, and then we're done. That is 100% the solution we're going to do, and I think it works. I don't think it has too many edge cases. I think it's hella interesting, and hopefully we will manage it all today. Crazy with Atlas generally will do. Okay, we're making a creature collecting type of game, but not like Pokemon. Pretty much the opposite. So instead of going out in the world catching creatures, you attract creatures to your garden and you make them want to live there. That's basically it. Pretty early in development, because I always, for some damn reason, end up in some pit where we are extremely low level trying to implement some weird shit that eventually is awesome. Yo, what's up, GDs? Hope you're having a wonderful Friday. Okay, so I love this. Let's see. So it's pretty much 2 steps. Convert into more descriptive format, and then analyze and convert. Those are the 2 steps our mesh parser has. So we convert it into a much easier format for us to parse, or actually into a format we need to be able to parse it. And then we're going to analyze it based on those data structures. I mean, we're basically doing like the very, very basic, or the very, very foundation of a modeling software. But yeah, Fabric, this is what game dev is all about. Hell yeah, it is. Crazy with Atlas, hey, quick question. I'm a noob to most of these things, but I'm trying to get into Blender. Currently I'm using 3ds Max for my college course. But do you know anywhere that provides all the information you would need to learn Blender? Oof. YouTube.com. Like, I don't know, it probably exists better places, but that's what I used. Yeah, like some of the tutorial creators over on YouTube for Blender are insane. Sorry, I don't have a better place than that. But good luck, and try not to get stuck in tutorial hell. So you want to be able to do stuff, or to be able to create stuff without watching tutorials, right? SmackGDs alternatively get a $10 course on Udemy. Yeah, I've never used Udemy, so, or watched any of those courses, so I can't recommend any of that. GDs, I finally figured out how to work with SOs, their strengths and limitations, and it's mostly limitations. Fuck man, you should do a write-up, because I'm hella interested. And I think it's a little bit negative saying mostly limitations, but maybe you're correct. Crazy with Atlas, thank you, and good luck to you as well. Okay, let's do this. What I'm wondering is, vertex, I think we're gonna do it as vector3, position, vector3 normal, fuck, writing this make me feel a little bit stupid, but we'll see. Let's just do this. Position normal, and then I want a int index as well. And actually, we're gonna make all of these public. And yeah, our constructor is just gonna be position normal index. There we go. Edge. Here we're gonna have vertex v1, vertex v2, fuck, I had it, there we go. And here we want to do, and that's not entirely correct. Here I want to do if v1.index is greater than v2.index, do something else. And I want to have it such that this.v1 is equal to v2, this.v2 is equal to v1. So we always have the vertex with the lowest index first, right? That's always our v1. And then we can do, I think we can do something like this. Or is this stupid? Public vector3 normal. Okay. Smack GDs, it's a subjective opinion. Yeah, I'm just assuming every opinion is subjective. Because if you're not a designer, it only gets in the way and you're constantly fighting the editor. That definitely doesn't sound too fun. And then we have triangle. And for this one, we are gonna do... We want to be descriptive here. We're going to use these to analyze, or these are going to be used to analyze a lot of stuff. So I wonder if we want to have the vertices here as well, v1, v2, v3, and then we have the edges as well, and then we have a normal also. Or is that weird? No, I don't think it is. No, it's not. We're gonna do it like this. Vertex v1, vertex v2, and vertex v3. But yeah. Mm. I'm a little bit worried about the fact that we are doing this here, but I think it's good. And then I want to grab, we had a triangle here, and I want get random point. We're going to move these, we're going to get these soon. Get bound points, get bounds, contains. No, what I want is area. Yes. I think we're going to start with this. Mesh parser. Fabig, let's make a petition to the EU Parliament that all meshes should have triangle sorted. Yeah, we're just gonna have to get, what is it, 100,000 people to sign it. Sorry, Mazik, we don't have a theme here. A theme command, that is. I think it's just VS Code dark with GitHub colors, yes. Nice eye. One sec. We can look it up real quick. File, preference, themes. I think it's dark modern, but I've changed some background color to be the GitHub colors. Yes. Mesh parser. Let's do public mesh parser. Mesh. Fuck. I guess we could do so we are gonna do private vertex. Primitives dot vertex vertices. Private primitives dot triangle times. Vertex count. I wonder if I want to do it like this instead. For each fuck, let's do it like this, of course. Okay. Vertices. Yeah, we want the index as well. We want anything else? Oh fuck, do we have normal as well? Yeah, we do. Mesh dot normals. There we go. And then when that is done, then we do the primitives triangle. Yes. And we do vertices I vertices I plus 1. We're gonna get a problem here. Yeah. No, I don't think so. Didn't we do... oops. Okay. So now we have a list of triangles and vertices after we have created this. And let's see. But do I want to... Maybe we want to convert it to polygons in the constructor. Like also, this is something I'm wondering about this one, the mesh parsers, because, okay, we're going to quit this. Because this is something I want to have in, like, let's say that we take one of these creatures. I want to stop this debugger as well. Let's delete this one and let's remove this one. Let's say that we're instantiating all of these stones. For each of these, like, we just want to calculate this procedural generation mesh parser once, even though we're going to use it for, I don't know what it is, 6, 8 instantiations, and then for X number of eyes. And like, I'm wondering if I don't want to have states or stuff like that in my scriptable objects. Don't think you should. But I think I want to have something here, like during runtime, we want to be able to fetch, like we're going to have a reference to the mesh of the creature here. But during runtime, I think we're also going to have, so when we fetch the mesh parser from this object, we're going to check, is it instantiated? Has it been used previously? If so, just return that instance. If it hasn't, calculate it. Because when we load one of our save files, we're going to instantiate a lot of different creatures, and given a seed, they're going to look a lot different, right? So yeah, we don't want to have to regenerate and regenerate and regenerate this mesh parser. So maybe it's a good idea, but it's going to lay there and take up a lot of memory. I don't know. We definitely want to store it for some, we want to cache it. And if we don't use it for a while, we'll remove it. But let's see here. Because what I'm wondering is if we also want to have private... Nah, I don't think we want to generate the polygons just yet, because polygons are gonna depend a whole lot on the rules. So once again, like, how big of a normal difference do we have here? Should they be the same polygon? And so on. But then again, we want to be able to cache this as well. Fuck. We can get to the... optimizations later, of course. So for now, we're gonna do public. Let's do, let's create a polygon. And it's gonna consist of a public list triangles. It's gonna have a list of vertex, and we're gonna call this boundary, I think. So these are a set of triangles. This is the boundary of all of those triangles, so just the outermost edges. And yeah, public polygon. I never know what's the best way to do this. I mean, let's go with, nah. What? Okay, let's do vertex, actually triangle. Okay, yeah. Fuck me. Could do it like this, right? Hmm. I should calculate boundaries better. Something like that, and a lot of work is going to go into this one right here. But we will get to it. Mesh parser. For now, we're going to put it like mesh polygon primitives dot polygon get polygons. And then we do vector3 or float angle threshold. Yeah, we're gonna refine this eventually. Pretty straightforward. Convert it to vertices or vertex and triangle, where we have some information. And then we're going to implement this one. But before we implement this one, and I need to run AFK real quick. I'm gonna, or not real quick, a couple of minutes. I'm gonna make myself a new cup of coffee because I think implementing this one is gonna get a little bit rough. But be right back. Okay, back. Sorry about that. So, I'm wondering about this angle threshold. So what we want to do next is we just want to go through all the triangles we have, and we want to compare normals, basically. We want to put them into groups of each other, but I wonder, we could take the easy way out here, I think. So when we say angle threshold, I wonder if, I think, like, you could do it the easy way out, I referred to just now, is that if we have an angle threshold of x, we just create a vertex or a list where we have, or a dictionary where the key is 0, x, 2x, 3x, and so on. But that will give us the wrong result. I reckon that a better way to do it would probably be to fuck, how do we want to do this? I'm pretty sure this is what we used the flood fill for in the previous solution. Yeah, 100%. Antonino, why I can't access the Discord? Yeah, I don't know. I had someone else with the same problem a while back. Let's see if I can hook you up with a personal invite. What happens if you try this link? No, it's no problem at all. I wouldn't be streaming if I had something against people interrupting me. Edge to triangles. Oh, yes. Yeah, if we want to do edge fill, we're gonna have to do this, and we're gonna need this anyway. We definitely want to do an edge fill. That's the best way to do it. That's the only way to do it, I reckon. But before we do an edge fill, we need to set up a little bit of a relationship. And that relationship is edge. We're gonna grab... Didn't we have this one here? Edge. Oh yeah, I put it... Here we go. Oh wait, was this? Ah. Yeah, we want to be able to compare these, so let's take these two. And we just take index here. Okay, now we can compare vertices and edges, I thought. Or do we need to explicitly, like, do we need to state I comparable? B1. Okay, yeah. Antonino, for some reason links are not working in the web version. I had to do it in the app. And I don't know why that is. Let's implement comparable. Yeah, let's do it. Compare to, yeah, let's do. What? Isn't it I compare we want? Fuck is it I equatable? And then we do equals, and then we have equals. Okay. We get hash code. Okay, this should be it. I'm pretty sure. But let's put this one here then. Doesn't matter if we do override, or we can't do override, but we do this. And here we do if. Yeah, in this purpose, I think it's enough if we do index is equal to other.index. And here we do object is vertex. If so, we do equals obj as vertex dot can we just do this then? Nah, no, 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 no. That explains it. Let's not do any fancy stuff. Object is vertex phi. If so, okay. But actually, can we just do... Oh, yeah, of course. We do it like this. What's up, processor chaos? So much cleaner to do this in C# than in Java. I haven't done anything in Java for I don't know how many years, 10 maybe. So I don't know how this looks these days. Okay, and then we do something similar for Edge. Hash code, we're gonna do like that. One sec. And object is edge E, and fuck, I want, can't we just compare? We don't need a hash code. E.v1 is equal to v1, and E.v2 is equal to v2. Can't we do it like that? Ah, get the fuck out. And now we have this issue again. Why? Antonino, enjoy that lunch. And you too. You too. Okay, we're gonna overload those as well. Okay, and then so now we can do this in Edge. Beautiful. And okay, finally. So now we can compare. I think we're gonna wait with these for the edges. Maybe we'll do them in the future, but let's see here now. So we need a way, we need to represent a relationship between, let's see here. Neighboring. Yeah, we need to represent neighboring triangles. We need a way to represent the relationship. So a dictionary where the edge is the key. Pretty much. Is this something we want to save here? Maybe. One sec. Fuck, I'm not so sure we want this to be struct. I'm pretty sure we don't want this to be struct. Or actually, it doesn't matter. No, I don't think it matters. So here we create vertices, here we create triangles. So for every triangle we create, we're also going to do for each edge in triangle. Let's do it like this. Primitives, triangle. We're going to do it like this then. Triangle, we can create a like this. Okay, what do we need? Do we need to... why can't we do this? Now we do if triangles per edge, which we need to instantiate. Let's do it like this. We need to do it like... and then we add it. Okay, so now we have this relationship saved as well. So for each edge, we know which triangles that use it, but feels like definitely feels overkill. I don't think I ever want to have a mesh where more than two triangles share an edge, right? That would be stupid. And this is where half edges come in, I guess. Right? Mm-hmm. Mm-hmm. Do we want to have... How can we store this relationship instead of having it like this? An edge. I mean, we could have... Edges could reference the triangle they are making as well. Mesh parser. Express this relationship in a better way? Question mark. We're gonna go with this one for now. Okay, so given a triangle, we now know its neighboring triangles, and we are gonna do a flood fill, which we already have implemented here. I just want to implement it with our new fancy structs. Polygon groups, and that's pretty much it. But we want this to be a list of vertices. No. We want this to be a list of polygons. Hash set visited. And we do it by triangles. Yeah, triangle. Okay, so I think I want to do it like this. List polygon. And then hash set triangle. Visited. Actually, let's take this one. Angle threshold. Oh yeah. Okay. Can we do... We're not going to remove stuff. No. For each but a bit of a triangle in triangles. If visited dot contains triangle, continue, then it already is in some group. Group Q. Fuck, do I wanna... Yeah, this is where we want to create a new polygon. Struct. would like to polygon, polygon, new polygon. Can we do it like this? And then Q, triangle. We don't have a proper comparison here, do we? Yes. How the fuck? This one isn't solvable right now, is it? Triangle. Let's make it comparable then. Okay. We just replace this with I have no idea what I want to put here. I guess it doesn't matter that much as long as it's unique. Don't we have anything in C#? Yeah, I guess it will work. And then we do if equals if triangle P Okay. Queue it, and we add it as visited. While queue count bigger than 0. Now we do triangle, triangle. It's neighboring triangle, I suppose. Or possible neighbor. Right? We have... No, we don't. Calculate boundary, public. Void add triangle. You know what? I'm wondering we might just take this one and add it here. One sec, did I fuck up? Yeah, this is the polygon, yeah. Polygon. One sec. Okay, back, sorry. Let's see, what do we have? Polygons, yes. Here I want to do, at the end here we want to do polygons dot add polygon. There we go. And we dequeue it, and then we add it to polygon. So triangles dot add n triangle. I really want to call it n triangle. And then for each edge in get p triangle dot get edges. Can't we do for each? Yeah, fuck it. Get edges. And if something, do something, otherwise we just skip it. Okay. Yes, so we want to check in our triangles per edge, and we want to go each of those. If it contains, we continue. Otherwise, we check the normal, add to visited, and chew. Okay. Try get value. We should always be getting a value here, I think. So I'm just gonna do for each primitives dot triangle and triangle. This is neighbor triangle in triangles per edge. Edge. If visited dot contains and triangle, continue. It's not n. Or actually it's both n and p. So we do p triangle dot normal and n triangle dot normal. If this dot is we call it angle threshold radians. There we go. I think polygons, polygon, triangles add. Get polygons. I think we can try this one now. Turn polygons. I thought. Okay, I want to try this one. Mesh parser. Yeah, we haven't calculated boundary yet though, but we're gonna get to that soon. I want to see if we can get. Yeah, we're gonna do a mesh parser tester, which is mono behavior, and we're gonna be able to set this one. And then we draw gizmos, and we should be able to draw each polygon in a separate color, pretty much. Set of triangles. Draw, cube, icon line. Okay, let's just draw some lines then. Yeah, we should just do it like this. Void, private void start. Mesh parser get polygons. Fuck, do I want to do polygons each frame? No. Polygons. But fuck yeah, we have this one. That's true. Never mind. Yeah, we're gonna leave this, I think. Quote, have you used Unity Graph Toolkit? I found it very handy for interactions and events-based game. Actually, I haven't. Might try it out. Probably. Yeah, I have a few ideas what I want to use it for. But I take it you enjoy it so far. And then we want to draw these for each triangle. Primitives triangle in but I also want to here I want to do gizmos.color is equal to color new color. Don't we have random dot color HSV? Let's try this. And then we do draw line triangle E1. Or actually we can do for each but we want to convert these to world coordinates. Okay, let's see what we get from this. Oh yeah, start. On draw gizmos if mesh parser Hopefully it doesn't crash. Like, that's not good. Hmm. Yeah, of course. Do we want to do -2 or something like that here? Hmm. Yo, what's up, Vito? How do you get ideas for developing games? I was wanting to deep dive on game dev, but I have no clue on what to develop. I can't relate. I'm pretty much in the opposite. But like, I play a lot of games, or whenever I get some free time these days. That's probably where most of the inspiration comes from. Have you never played a game and thought like, I want to do something similar to this, but with X instead of Y, or something like that? That's usually how an idea of mine starts. And then while developing it or thinking more about it, it usually diverts quite a lot from the original inspiration giver, you know? But okay, yes, we're gonna get a problem here. Over on YouTube, sorry, I don't know how to reference that name, but quote, I don't like games, so I usually benchmark from real life and simplifying it to a game. Like, that's I think that's a, like, respect, but I have a hard time, right, like, relating to that. So you don't like playing games, but you like making games. That's also it's a very unique position to be in, I think. Vito, yeah, makes sense. Thanks, mate. No problem at all. And thank you for the follow. Appreciate it. Okay, back to this one, mesh triangles. Yeah, of course, we're going to go above and beyond. What do I want? What is it I want to do here? Don't I want to do -2 here or something like that? Rather, I'm into, you can call me Kevin. Thank you, appreciate it. Okay, Kevin, rather I'm into game systems. Yeah, I mean, like, I'm not judging. I'm just having a hard time relating to it. But then again, I've had periods in my life when I haven't enjoyed gaming as much, but I've still enjoyed making games. So yeah, and game systems are extremely fun. Although I'm wondering how we did it previously. We had something like this. Triangle normals, new vector. Triangle's length. Here we do triangle's length. And we do I +1 +2. How the hell does this one not prompt an overflow? Oh, I'm wondering about this one. And here. That's weird. Okay. Nah, it should be okay, shouldn't it? Because when we jump up... So if we have three triangles, we have 9. So we start from 0, 0, 1, 2. Then we have 3, 4, 5. We have 6, 7, 8. And then plus 3 again, and we're above. So what the fuck? Is it this one? Twenty-four, 24. Yes, fuck yes. Or no? Yeah. We don't want to use I here. We want to use... Actually, we want to keep those, but we want to add mesh dot triangles. That's how we want to do it. One sec though. Yeah, this is how we want to do it. I'm pretty sure. Hmm. Pretty sure we aren't able to do this for some reason. Use debug, but we're not running the program. Like, we're not running the game right now. In fact, this one sucks. Why is this a thing? Debug assert. Where do you want us to put debug assert? Like, so far, like, all of these errors are pretty straightforward. And we know exactly, like, they point, like, we know what's null. Polygon is null. So we don't need to debug just yet. But I want to fix this one first. Or it's rather not polygon being null, but the triangles list being null. Which is why I would want to do something like this. This is okay. Which is fucking weird. We could... So we're trying to get triangles here. But this feels weird. So we have a struct. When we instantiate it, we want to give it a list. Let's do it like this then. New polygon. There we go. Okay, I want to remove... It's hard to see, but I think we're A-okay. I think we are. Here we have an override. I think this one is pink and green, actually. But we're not done yet. This looks pretty good. And then I guess we can go crazy and we can take this one and we can change the angle threshold to be 45. I thought we would be getting more of the same color then. I guess we are. This one and this one. Or if we did 360, then we get the same color on everything, I thought. Are we doing the opposite? Because now it looks like... Zero works. Very good. And 45. Yeah, it depends on the flood. It looks good, looks good. The only thing I'm wondering is angle threshold 180. Shouldn't them all be the same color then? Kevin, where is a cosine? Have I missed it? A cosine. Oh, we're talking about this one, right? Fucking hell, man. Nice catch. This way of visualizing it isn't the best. Still think we're getting the wrong. Did I add it? Does make to have 360? I know. I think. Yeah, I'm wondering if we're splitting. I think we're splitting the mesh earlier anyway. I want to see 3D object, sphere. This one is. Maybe. Holy shit, that's pretty fucking cool. 45. 90. 180. 360. Now we're just going up to 180, I think. Kevin, A-Line is a good tool for visualizing. I use it in every project. A package called A-Line. Writing it up. Okay, we're gonna research later on why. I think that this result looks good. I'm a little bit worried about some of the results here, but for the most part it looks very, very good. We're going to continue. We're going to take it one step further and see if we can simplify this into one polygon or boundary. I want to get the polygon boundary. But before we do that, I'm going to run AFK real quick. So be right back a minute or two. Okay, back. Let's see if we can finish this today. So I just want to save. So every edge within a polygon group. We only want to keep the edges that are used by one triangle in each group. Right. Do we have this information, or can we save it from? Or like, can we calculate it from? Or during we do this? Let's see. Or actually, I want to do it within polygon, I think. Boundary. Or do we want to make this one as edge? That's probably better. Calculate boundary. We're gonna have to do new. I wonder, is this something we want to... Yeah, we probably want to use this quite a lot. Like, I'm wondering if it's a better idea to just have this one as a class. It was a Blazamat. Yes, this is math class. Polygons add. Having this one as struct, I don't know. Since we're adding to it over and over again, maybe we could do polygon. Maybe we can yeah, if we're gonna have it as a struct, let's make it... Yeah, let's not create the polygon here. Okay, let's do it like this. This triangles equal to triangles, and then we calculate the boundary here. So I don't want to do this here. Instead, we want to do list primitives dot triangle. And then here we just do this. And here we do polygons, add new polygon. Like that. Okay, now it works a little bit more like a struct. Lazamat, anything to show in the game, or is this all just code for now? You can check out my YouTube. We have a few things, but it's mostly just code now. Okay, the way we want to calculate this boundary, fuck, do we need to send in? No, I don't think so. We can calculate it here as well, but it's a little bit weird. Maybe. Could we do it like this? Maybe it's not. Yeah, we could do it dictionary style, like the previous solution or implementation. Or we could do it list style, but if we have a lot of triangles, yeah, that's gonna suck. Yeah, we pretty much want to do triangles per edge. Yeah, we want to do this again. We could send this one in again, or send it in here, or just recreate. Let's just recreate it. We filter. That's kv dot value, I suppose, value, but it's still fucking weird, man. Dot keys. What happens if we do two lists? Where? Select. There we go. That's our boundary, I think. Kevin, technically, the mesh can be sorted into a binary tree with some loops and a grand root node. The connections can be an edge. Yeah, maybe. I'm just trying to wrap my head around. I'm way too burnt out in my head right now to wrap my head around that, or why we would want that. But if you send me an example, I would love to look it over. Let's see if we can print the boundary now. Mesh parser tester. Public, private. Something like that. You know what? Hmm. I want to be able. What the do we have? Yeah, we have something. Or no, we don't. We don't have anything, right? Or maybe if. Ah, show polygon boundary. Yeah, we have something here. Ooh, I think it looks good. Let's disable the outlines. Yo, what's up, Apukas? Happy Friday, happy Friday. Actually, I haven't looked outside today, how it looks where I am. But Google tells me it's not currently raining, at least. It's just cloudy outside. Okay, I think this is beautiful. Yeah, we have some pretty good progress today, I think. I want to double check. Look at this. This is currently what we're working with, a mesh parser, which is going to be used quite a... we're just converting a mesh into a more analytical way of representing it, and then we analyze it. And we analyze it to be able to alter it and spawn stuff based on it, eventually. But I want to try something here. I want to check... I want to see if we can do... show boundary angle threshold. I just want to show... Or you... Nah, we don't need this. We are gonna... I want to be able to like offset these boundaries inwards. So... to be able to do that, however, we always need to be moving in the same direction. So we need to get... we need to create some type of circular or a direction to parse these, I guess. And that is why we want boundary to be vertices instead of edges, because edges, they are always they are based on index. We don't want to do it with, we don't want to base it on the indices. So when we have this boundary here, fuck it. Could we just do .v1? No. Focus to your health. I'm drinking tea. Oh, nice. Yeah, I'm drinking the last cup of coffee here. But I will only be able to stream like 30 minutes more. And after that, I promise you, I will go grab a glass of water. Yeah, I don't think we can only take V1 here, but we could... Let's see, first of all, we're going to make this into vertex. A fine glass of water, yes. Hmm. What is... Fuck, what is the best way to... How did we do it previously? And yeah, it was this one, sort edge loop. This one didn't work. Or this was one of the things that didn't work. Why didn't it though? Isn't it pretty straightforward? If we were to mimic that, we could just do... Wait one sec, how would this work if we do... This one might go this direction and this one might go this direction. That's the start, that's the end. Yeah, how the hell would that work? Hmm? No, I think we can do this in a better way, right? Shouldn't we be able to... Yeah, we should be able to do this based on winding direction of our triangles, I think. Yeah, definitely. We can build this. I think we can build this earlier. This is one of those type of, let's see here, triangle edge. Yeah, we always go V1, V2, V3. What's the reason I want to do this? Nah, I think fuck this actually. If we have it like this, if we keep it like this, then we can always calculate. We always know that we're moving V1 to V2. One sec. Okay, back, sorry. Apokas, it's crazy how mental gymnastics you need to do for these types of operations you're doing. Yeah, I agree. But let's see, I'm trying to, if we always store V1 and V2 in the direction of the winding order of the triangle, we should be able to calculate then we should be able to do this type of walking through it. But fuck, I'm also thinking I'm rethinking having these as structs because we might... No, we're gonna keep them as structs, but let's see here. Okay, so let's remove this one. So now we store them like we get them. So in the winding order, we should be able to create or calculate a tangent and stuff like that with this as well. Tangent and binormal. But we should also be able to do this, i.e. for edge in boundary edges. Boundary. Boundary loop, new, and then we do boundary loop dot add edge dot v1 dot v2. And then we do boundary is equal to new. But we want to start with any specific one. Okay, boundary edges. .v1. Okay, I'm just gonna add a fail safe here for now. Oh yeah, we want to add boundary start as well too, don't we? Or actually, we want to do it first here, don't we? So boundary dot add current. And then we do current is equal to boundary loop. Let's see if we get the same error this time around. I don't know. Let's try it. And yeah, after this should be our boundary. It up. I fucked it up. How the fuck is it possible? What? Show polygon boundary. Polygon boundary. Here we remove edges. So boundary edges only has edges that are used once. In boundary loop, we just add this and this. Yo, what's up, Jack? Still streaming, bro? Yeah, but I'm starting to lose my my sanity now, so we're probably gonna call it real soon. Fucking hell, why did we get... Extremely weird that we got the... Now we no longer only have the boundaries. Okay. How did we... I'm still... We had a better result previously. It's like we get... Now we get the... every triangle edge once again. How did I manage to fuck this up? How did we get this line again? We stored this edge, no matter how. Or did I boundary loop? Boundary edges. Fuck this. This doesn't look good at all. What bothers me is if we do this, let's see here. Oh, maybe. Nah. Or nah. Let's see here. Okay. The problem is when we drew these edges only, then we get a good, nice polygon boundary. But then when we try to sort them and get them clockwise, or we want a loop to have a direction, so to speak, that's when we start getting edges within the polygon as well. That doesn't make any sense. So here we basically just take each edge and set the vertex as key, the start vertex as key, and the end vertex as value. It's unfortunate, but I'm gonna have to run now. So unfortunately, we didn't get this fully done today, but I'm pretty sure we're gonna get it in place early on Monday. And then we can continue with the Sten creation, or creatures in general. Thank you so much for watching, everybody. Appreciate it. And have a great weekend. Peace.